Then I did some tests of parsing XML, and it's absolutely horrible. I mean, the overhead you have to parse just to call a function in SOAP takes minutes. It's ridiculous. So I extended HTTP and made a very small, simple protocol, because at the end of the day, the only thing you have to transmit is call this on this is a reference to this. And this is just a little comparison. If you look at the SOAP and the objic protocol of the execution time and the system calls and the file size of the call, well, even if you don't believe it, your handheld device going over some 3G network, data size is still vital. I mean, it's still important. And so SOAP was just far too slow for anything to go in real time or even be usable in my eyes. So the source code, can everyone read this? No. So basically, you can have classes, user-defined classes, so that you have a class, you compile it into bytecode, and then you can ship it off to your cloud server. This cloud server can be locally on your computer. You have no problem in development. Like for a test thing, I wrote everything on my computer locally, and then I just said, I changed, okay, the object location now is on a server I had in America. And I just had an object server running there with the same class files, and it worked. Because you just say, okay, all my mail objects at that time are on my server in America, and then all mail objects will go off to America. And then they live on the American cloud server, and you can access them locally from your home machine. So it's very easy for you to develop an application locally on your machine and then move it into the cloud, because you're running a cloud server effectively on your machine for standard in and standard out in the first place, because you want them to be local. Whereas a friend of mine, he had standard in and standard out on a log server, and through that he was logging everything the program was putting out, and then he sort of said, okay, now I've got the log files, and for this he moved everything into the cloud. He had his Amazon S3 storage, and that was his log files, and he just saved it there, and that was it, and he copied them. So you have functions, the usual stuff is you can see the Python def main, and you have args, and you have input outputs, strings, int, whatever. And it runs. So everything's written in Python for now. That will change soon, I hope. So basically, objic is the compiler, and then I compile it, and then I run the example with 5, and it multiplies all the numbers till 5. So, what are the main features? What are we gaining out of all this? So we have distributed object instantiation in a very easy syntax. And that's a main thing, because every time I saw, oh, we can have distributed objects with some middle layer, it's very hard to set up. No one understands it. There's one nerd in the company that really knows what it's doing, and no one else understands what's happening. It's very easy, because you can specify in the source code, these objects live on that server. You can say globally for this program, these objects live on that server. You can say for this class, these objects live on that server. So it's very easy to see what's happening and to distribute the object instantiation. You have base objects. Everything extends from one object, as you know from Java or whatever. So that's quite nice, because everyone has a default output filter, so you can debugging is easier through this. User classes, that was a main thing. That was when that was reached, that was a big step. You can now define your own classes and ship them all over the world and use them out of different programs, and it all seems to work. Different stacks. Conditionals, memory management is a big problem, because you've got no idea how long that object is going to live. Because you're pushing pointers. If you say add this, if you've got two objects living on two servers, and you say add that value to that value, you lose a reference, and then adding those is very complicated at the end of the day, because you don't know what is pointing to an object. Is the network connection down? It's very hard. So memory management is a big problem, and there are lots of papers being published on this, and I've done some research, and it's really, really hard. I mean, distributed memory management is always hard, I suppose. You have while breaks for user functions, returns. Everything runs on an object server. That's important too. Everything you write runs automatically in an object server. So everyone who has this object server running on a machine can implement your class. So you can easily distribute, or you can say, let's say you've written a really, really good encrypt function, and you say, okay, I want this for the world. I want people to be able to encrypt their objects with my encrypt function. You just say, okay, my object server is public viewable, and you make a little website saying, hello, this is my server, and this is my encrypt function, and then everyone can access and copy their objects onto your server, you encrypt them and send them back, or send a reference back. So you hold the data. This is quite important too. For example, if you've got a big company, and you, let's say you have mail objects, you don't really want those mail objects to be hosted by Google, or I wouldn't want them, because if they will peek into them, you don't know. And so what you can do, you can have the mail objects locally on your computer, but have all the functionality from Google. So let's say Google will sort your or search your mail, but only the headers, so you can only transfer the headers to the Google server and say, look into the header file, or look into the titles of the mail, but you're not publishing your body of the mail, what's important, or whatever you see important. So and user classes 2 times. So a problem. So I was just explaining that you can basically have objects on different machines and you use them, and it's quite seamless. What happens if that guy who provides this object server decides, oh wait, this sort function is broken, and changes it, but you rely on that error? I mean, there was a big thing in Java and people were actually relying on this to error and actually used that error. So you've got an object versioning problem, because if someone updates the object and it's not your object, or the class, the base class, let's say, you instantiate the object, your program will fail because you don't know this has happened. So there has to be some versioning system. That's not that simple, because obviously you want bug fixes that don't affect the output or the black box. You want those to happen, but you want white box bug fixes. You want to see those and you don't want to use those. So should the service provider have 20 class files or objects lying around, or how should that happen? There's no real solution yet to this. Inheritance is quite difficult, because that sort of builds on garbage collection. If you inherit from an object, are you going to copy the struct, or how are you going to do that? Public, private, for now everything's pretty much private, except if you specifically say, do it. But then of course you want specific data to be public and private. For example, if you've got a person object internally to your company, you want all the data to be public. But to the outside world, maybe you only want the name and, I don't know, the email to be visible, so you can have a website or something. So it's not that easy to say, is this going to be public, private, or what is this going to be? Garbage collection, as I said, and security is a big issue, really, in the whole cloud computing thing. Sometimes I'm amazed what people just do. They upload all their financial records onto the Amazon cloud, and then they say, yeah, that's in America and everywhere, and I don't really care who can see it, and it's the main core of the business, and they just upload it into the cloud. And I'm like, okay, would you really want to do that if you're like the boss of a company? And I don't think people really understand the real security issue that this whole cloud thing is bringing. But, yeah. So, the future, or what I think the future will be, obviously no one can see into the future. I think cloud providers will have to sort of agree on some sort of protocol to talk to each other, because it's just unacceptable to be locked into one service provider and then relying on him to do everything for you. And if you want to use something else, going through SOAP, going through all these protocols and reverse engineering it back, somehow it has to be more scalable, that you can use different storage providers, that you can use different CPU providers. Actually, why do we have to care about this? You know, why does it matter? Why can't I just move my data instantaneously? Why do I have to migrate all the data if I move from Microsoft to Google? That should just happen like that. More data is going to go into cloud.